Okay, so for the back side of the test, it says find the average rate of change, which means slope. And think I saw most people doing this correctly, the idea correctly, and they made some arithmetic mistakes. So when you plug 3 in here, 3 cubed is 27, and minus 6 times 3 is 18, and then we're going to add 9 to that. So I think we get 18 for this guy. On the next one, if I do f of negative 1, I get negative 1 plus 6 plus 9. So I think I get 14 on that one right there. So if we take the difference of the y's, 18 minus 14, all over the difference of the x's, 3 minus a negative 1. I mean, there's all kinds of chances to make mistakes with your positive and negative signs, but I get a slope of 1. That is the average rate of change. It's the slope between those 2 points. It's the slope between negative 1 comma 14 and 3 comma 18. 3 comma 18, right? Next one, number 8. We could skip number 8 because it was exactly the same as problem 4 on the front side, where we're doing f of x plus h minus f of x all over h. Down here on number 9, we're trying to graph this piecewise defined function right over there. Let's say we had y equals 4 plus x. Okay, the y-intercept is 4, so I come over here to 4, and I know this problem, so I'm going to put an open circle right here. If I didn't know it, I'd have to go back and study a little bit more. Do you see how it doesn't want at x equals 0? This is not the function at x equals 0. The function's down here at x squared. So I'm going to come down here and I'm going to put a dot down because I know x squared, looks like this. I go over here to 2, I go up here to 4. So I've got the parabola over here. That's x squared, and you see I've got a solid dot right there at 0. Here I've got an open circle, and I want to have a slope of 1, so I go, let's say, down 1, back 1, down 1, back 1, down 1, back 1, down 1, back 1. Okay, so there's my x-intercept. I have a target now where I can draw a line to, right? I'm trying to make it as straight as possible. And I saw some people curve this line. I was kind of curious, why is this line curving? And I saw that on the whiteboard. I wasn't sure if it was like an error in trying to use the whiteboard marker, and it's kind of awkward sometimes writing on the whiteboard. But some people curve this. Well, I mean, it's a line. So I don't think I took any points off. I probably should have if you had it curving over here. But this is what our graph looks like. So what is the domain? The domain is all these x values, right? And that's all of them. So does it say if it wants it? It doesn't really specify, so you could just say all real numbers right here, all real. You could go interval notation, negative infinity to positive infinity, right? On the range, it's going down forever over here, so it's covering all values to the to below, and this one's going up forever, so it's all real again, all real numbers. Or you could go negative infinity to positive infinity. Let's make sure we label our intercepts on the graph here. So here's one intercept at negative 4 comma 0. My other intercept is over here at 0 comma 0, right? I hope I'm making that clear how to graph these piecewise defined functions. We're graphing the line for all x is less than 0. We're graphing the quadratic, the parabola, for all x is greater than 0. Number 10, find the function that is finally graphed after the following transformation. So how do you reflect it over the x-axis? You go like this, y equals negative square root of x. How do you shift the function up 5 units? You go y equals negative square root of x plus 5. How do you shift the function left 8 units? You go y, I already have my y over there, I don't need another y. See, my y is that f of x. I just need negative square root of x. Make my square root sign a little longer. You want to put the 8 inside the function. To shift it left 8, we're going to go, let's speed it up, make it happen 8 sooner than it normally would happen. That would shift it left 8 spots. And then we're going to move it up 5 units. Okay? Number 11, you see a triangle there. And so what I want you to think about, they want the area of the triangle. So if I go area is 1/2 base of a triangle times the height of the triangle. Well, the base could be considered like this leg. When you have a right triangle, the base and the height are the legs, and this is the height. So let's see, I could put in for the base some x value, right? I'm at some x spot right out here. Isn't that an x length? So I'm going to put x in for the base, and then for the height, I'm up some y value. This is our y value right there, right? Now, I'm not completely done, but if I saw this kind of work on there, you got a lot of partial credit. It does say I want an area formula for in terms of x. So like this could be maybe clear if we were to put a of x equals, or maybe that's less clear, I don't know. But I can't leave it like this. I can't put 1/2 xy down. So, well, x is good, but the y is no good. But y is equal to x to the 5th power. So I put x to the 5th power. When you multiply, you add exponents. Why do we do that? Why do we say 1 plus 5 and put x to the 6th over here? I'm not done yet. That's not my final answer. But the reason why is how many x's are being multiplied together here? 5 of them. How many x's are being multiplied over here? 1. So that would make a total of 6 of them, right? And then we have the half still. We haven't done anything with the half. That's our formula for this triangle right here. All right? Thanks for watching the test corrections. I hope I'm making that clear. Please write all your corrections in a different colored pen or pencil.